Hello students of ICSE board 10th standard. I am Abhijit Peshkar, and in this video we are going to study the chapter force and the turning effect of force. In your 9th standard you studied the chapter force and about the concepts of force, the Newton's laws of motion, right? In this chapter we are going to study the turning effect, that is the rotational motion, right? So there are two motions. I think in your 9th you studied about the linear motion, and now in 10th you are going to study about the rotational motion, जिसको हम turning effect of force. The turning effect of force, जिसको हम बाद में torque ये नाम से भी जानेंगे. So we are going to study this in your 10th plus equilibrium. So I am going to cover all the topics. So stay tuned with me. I am Abhijit Peshkar and you are watching Physics Forum and Sakar PCMB. Okay, so let's get started. In this chapter we are going to study the turning force concept, moment of force which is torque, forces in equilibrium, the concept of equilibrium and the conditions of equilibrium, the center of gravity, discussions using simple examples and simple direct problems. So we are going to see everything in this chapter. Okay. Scope of the syllabus: elementary introduction of translational motion, rotational motion, the difference that we are going to see. First, what is the difference between the translation motion and rotational motion, and moment, that is the turning effect of force, also called as torque. I was telling you this only, torque. Its unit, CGS unit and SI unit, right? Common examples: door, steering wheel, bicycle, pedal, etc. So we are going to see everything. I'm going to teach you with the help of examples, some real life examples, and also with the help of few animations also. Okay, so without any ado, let us start. So first tell me in the comment section what idea you get from all these three pictures. It's what insight you are getting. So in each case you can see that there is force, obviously there is force, but the effect of force is not to move the object but is to rotate the object. You can see here, as the weight on the right side is more, so the system got tilted, it got rotated, it got a torque on that side. So in vector terms it is inside, because we use the right hand rule that I'm going to discuss with you later. Here you can see that there is a lever, and with the help of a lever we can rotate the screw, right? Here you can see a screwdriver, right? That is a bolt. With the help of a lever we are rotating it. Here you can see a screwdriver, and with the help of this screwdriver we are fixing this nail in the wooden block, right? So in all three cases there is force. Yes, obviously there is a force, but here the effect of force is not to move the object in one direction, in a certain direction. So there is a different kind of motion that is involved here. So before I jump on that topic, tell me what is difference between these two motions. Think for some time and tell me what is the difference between these two motions. In this case you can see a ball moving in one direction, that is a straight line, and this type of motion is called as a translation motion, translational motion, or linear motion, or a rectilinear motion, a rectilinear motion. While in this diagram you can see the fan is in rotation, that the center of the fan is not moving. The center of the fan is not moving. The entire body, all the particles in that fan is, they are moving about a fixed axis. This is the fixed axis. Yes. So you can see the body itself is not changing its position. The body itself, the center itself is not changing its position, but it is rotating about some axis, and this is called as a rotational motion. So this is the difference between these two motions. You can take the notes that in linear motion or in rectilinear motion, what happens is all the points of the body, all the points in the body, they all have the same direction. You can see all the points are moving in one single. This is a linear motion, and here you can see this particle is moving in this direction, while this particle is moving in this direction, and this particle is moving in some other direction. So all the points have different directions for the velocities. Even the magnitude is not same. You can see, At this point, the velocity is more because it is covering more distance. For the point which is closer to the axis, this point is having less velocity, less magnitude of velocity because it is covering less distance. Can you see? But in this case, all the points will have the same velocity. So this is the difference between linear motion and rotational motion. One more thing I think you should note and also write in the comment, which can give me a hint that you are watching the lecture properly. And that is, here the force alone is responsible. Force alone is responsible. But in this case, with the force, we need one more physical quantity. And what is that quantity? Tell me. With the force, there is one more quantity that is involved in this motion. And that is a new thing for all of you. And we are going to study that only. Okay? So let us see what is there in your text. So here you can see translation and rotational motion. The definitions are given. A rigid body, when acted upon by a force, can have two kinds of motion. Yes, we know this. Whenever there is a force, the body can have two motions. Right? First, there is a linear possibility of a linear or translation motion. So what is linear motion? When a force acts on a stationary rigid body which is free to move and the body starts moving in a straight path. So this is important. Underline this. The body moves in a straight path, okay, in the direction of the force. So these two things are important, and that is called as a linear or translational motion. Okay. Then what is rotational motion? See, if the body is pivoted at a point and the force is applied on the body at a suitable point, what I can tell you is, see, this body is pivoted at this point and the force is applied somewhere here. There is a coil inside the fan on which there is a magnetic force. Or simply what you can do is you can apply a force with the help of a rod or any stick. You just apply force here and you can see the fan will rotate. So a force is applied at a suitable point. Suitable point. It rotates the body about the axis passing through the pivoted point, and because of which there is a rotational motion. So in rotational motion, what if, my question to you is, you can answer in the comments, what if I apply the force where the body is pivoted? Let us say the pen is pivoted here. Try this yourself. And I apply the force here only. What will happen? Will the body rotate or what will happen? What is the important significance of that word at a suitable point and in a suitable direction? You have to think. Okay, this turning effect of a force and the motion of a body is called as rotational motion, and this is called as rotational motion. Simply, you can see there is a pivot, there is a force, and because of which the wheel is set into motion. Okay, let us move. Then, so here we have completed just the introduction part of what is linear motion, translation motion, and what is a rotational motion. Now, my question is, how can a body be set into rotational motion or in rotation? So first, that we just have seen with the help of example that you need to have a body which is pivoted at one point. This is the point, okay, and you are applying the force here. This is the force F, and this force is, at some distance. This is a perpendicular distance. This distance is very important. Okay, this is the perpendicular distance, and this distance is very, very important when you produce the rotational effect. How? Just go take the mobile or the laptop and just go near your door. Yeah, the door of your room. So, and try this. Let us say this is the door. Okay, this is the door. Okay. And what you can do is first apply the force at this point and see how easily the door is set into rotation. Then slowly shift your force from this edge to this point, and finally apply the force here. And you will see that when you apply the force at the end, at this point, it is easy to rotate this door easily. It is easy to rotate the door when you apply the force at this edge. So the force is same. Let us say force is F. The force is same, but this distance, as it is changing, the amount of force that is required is also changing. What I mean to say is, if you have this pen, let us say, let me come closer to the camera. If I apply the force here, you will require some amount of force. But if you want to rotate this pen and you want to apply the force here, you will probably require more force. See, you can feel this. Take a water bottle and do this. Apply force here, it is easy to move. Apply force here, it is difficult to move as compared to this point. And if you apply force here, it is impossible to move. See, apply force here, it is impossible to move this water bottle because the perpendicular distance is 0. And so this is very important physical quantity when there is a rotational motion. This is a very important quantity along with this force. So only force is not important, but this perpendicular distance is also important, and the product of these two, the perpendicular distance and the force, is called as moment of force. Moment of force, and this is called as the torque. This is called as the torque. Are you with me? Let us see what is there in your text. So moment or the turning effect of force is, you can see there is a body. You can see this is the pivot. When the body is fixed here, this is the perpendicular distance and this is the force F. See, can you see? Yes, I think you can see. There is no problem in this. Okay. Now, the force F is applied horizontally. Okay. Then the important word is the force is unable to produce the linear motion of the body in the direction because it is not free to move. So the body is pivoted, na? It is pivoted. It is not like this water bottle. I have fixed it here. So if I apply the force, the body is not able to move because it is pivoted here. Okay. And but this force turns or rotate the body about the vertical axis passing through the point O in the direction as shown in the figure, and because of this the body is rotating in anti-clockwise direction. Obviously this is the anti-clockwise direction. It can also rotate in the clockwise direction if you apply the force in this direction. So even the body can rotate in this sense also. Okay. And what are the factors that affect this turning effect? And the factors are magnitude of the force. Yes, how much force I am applying. Am I applying a small amount of force or I am applying a greater magnitude of force? This is also important. The distance of line of action, distance, this is also important. The distance, what I was telling you a couple of minutes ago. So this distance of line of action of force from the axis of rotation, and this distance is taken from the axis of rotation. You can see this is the axis of rotation. This pen is itself the axis because this is fixed and the body is rotating about the axis like this. So this perpendicular distance is very, very important. So the magnitude of the force and the distance, perpendicular distance. So here let me ask you one question. So if this is the body and I am applying the force in this direction and I take the distance from the fixed point, and let us say I call this as R1 and the force F, and if I ask you what is the moment of force, so will you say R1 into F is correct, or will you say it is wrong? Think. Is this the correct formula of moment of force? And I will say no. This is not the correct formula for moment of force, because for the moment of force we require the perpendicular distance, and this is the perpendicular distance. Let us call this as R2. So R2 into F is the correct formula and not R1 into F. This is not the correct one. I can give you a formula in which you can use R1. I can give you that. Let me give you. So let us say this is the angle theta, and using the I will prefer using this angle C, because this is the direction of R1, this is the direction of R1 vector, and this is the direction of force, and this is the angle theta. So the opposite one will also become theta, opposite angles. And if I use sine theta in this, sine of theta, you will get opposite side is the perpendicular side is R2, and the hypotenuse is R1, because this is 90, so this becomes the hypotenuse, and from here you get R2 is equals to R1 into sine theta, and now you can replace this R2 with R1, R2 with R1. So here you can say it is R1 sine theta into force. This is correct, but if you directly multiply R1 with F, it will give you the wrong answer, because for the moment of force you always require the magnitude of force and the perpendicular distance to the force, to the line along which the force is acting. You getting the concept? So let us see what is there in your text. Okay, so in your text you can see the force and the perpendicular distance. This, the product, gives the moment of force. Note, for producing maximum turning effect on the body on a given force, by the given force, the force is applied on the body at the point for which the perpendicular distance of the line of action of the force from the axis of rotation is maximum. Common sense. If the distance is more, you get the more turning effect. If the distance is more, you get the more turning effect. What do you think? So that the given force may provide the maximum torque to turn the body. So the unit of this is, let me tell you, the unit of this moment of force is, it is perpendicular distance into force, and the perpendicular distance is in meter, force is in Newton, so you get Newton meter as the SI unit. SI unit. And if you want the CGS unit, it is for distance it is centimeter, for Newton it is dyne, so it is dyne centimeter. Dyne centimeter. So now I have a question for you. 1 Newton meter is how many dyne centimeter? 1 Newton meter is how many dyne centimeter? Before I tell you, you can try. See, there is different, a feeling of happiness when you are able to do it yourself. So I know you will try. You will try. So the answer is 1 Newton, we know it is 10 to the power 5 dynes, and 1 meter it is 10 to the power 2 centimeter. So if we multiply this, you get 10 to the power 7 dyne centimeter. So 1 Newton meter is 10 to the power of 7 dyne centimeter. I hope you were able to solve it correctly. Okay, so now let us see the direction. Okay, let us see the direction. So this new term, that is moment of torque, obviously is a vector quantity, because it is when it is rotated, it is having some direction involved. right? It can rotate in this clockwise sense or anti-clockwise sense. So it will have a direction. And what is the direction? So the direction can be that the direction is given by the right hand rule. So let us say if there is a wheel and the wheel is rotating in this direction, anti-clockwise sense, we use the convention, and for that we use the right hand. Simply curl your right hand in the direction of the motion, like this. Okay, and this is the direction of the motion. Let us say angular velocity. The velocity is in this direction. But is it the direction of the torque? Think. So there is a logic here which I want to tell you, and that is, if the moment of force that you are providing, if it is increasing the velocity, let us say it is increasing the velocity, then the direction of your moment is in the direction of the motion. Okay, but if you are applying the torque in this direction, yeah, let us say you are applying the moment in this direction like this, and the body is slowing down, the motion, the speed is decreasing. So in that case, you will have to say you are applying the moment in the opposite direction, because of which the speed is decreasing. Or for simply, for your text, as per your text is concerned, let us assume the body is in rest. So I will draw a lever here. The body is in rest. And I start moving this. So if I rotate in this direction, just take your hand, curl the right hand in this direction, and you get the thumb outside, and this is taken conventionally as positive. So anti-clockwise is taken as positive, and if the same thing you rotate in the opposite direction like this, take your right hand, do this, rotate in this direction, and you will see your thumb inside, and that is conventionally taken as negative. So clockwise is taken as negative. Let us see what your text says. So you can see conventionally, if the effect of the motion is to turn it anti-clockwise, it is taken as positive, and for clockwise it is taken as negative. Okay, then there are some examples. The moment of force is a vector quantity. Yes, this is a vector quantity, and the direction of anti-clockwise movement is along the axis of rotation outward. Anti-clockwise is taken as outward towards you, and clockwise is taken as inward. Clockwise is taken as inward, anti-clockwise is taken as outward. Okay, so there are some examples. Let us say example number 1. To open or shut the door, there is a door, you can see there. To open or shut the door, we apply a force, that is push or a pull, normal to the door, that is perpendicular to the door, and to its handle P, which is provided at the maximum distance from the hinges. The handle is always provided at the end of the doors, right? This. The handle is never in between. This is the door, and you will never find a handle here. You will find the handle here, right? So we can notice that if we apply the force at a point near to the hinge, much greater force is required, and if we apply the force at the end, you will require lesser force. Okay, so that is the same thing that we discussed earlier. If we apply the force away from the axis hinges, lesser force will be required because the distance is more, so we will require less force. But if you reduce the distance, then you will require more force. Okay, and they are discussing about the direction. You can see that this is anti-clockwise, the direction is positive. This is also anti-clockwise, the direction is positive. Same thing, anti-clockwise rotation, clockwise rotation. Clockwise is inside, anti-clockwise is outside. So I want you to read this thoroughly. They are the same things that we are discussing. Okay, so this was part 1 of this topic, moment of force and equilibrium. For part 2, go to the description you will get the link of part 2 and also the link of the app where you can get the next series, more chapters, more test series, and whatever you require for your preparation. Okay, so till that time, do prepare well, enjoy physics. See you. Bye bye.